Locked-rotor refers to a specific state within an electric motor. This state occurs when the motor's rotor, which is the rotating component, is prevented from turning, while electrical power is still being supplied to the stator, which is the stationary component of the motor. This situation often arises during the motor's startup phase. At the moment of startup, the rotor's electrical resistance is typically high. This high resistance, in conjunction with the inertia of the rotor and any connected load, can prevent the motor from generating sufficient torque to initiate rotation. In a locked rotor condition, the motor exhibits a characteristic behavior of drawing a very high current from the power source. This current is known as the locked rotor current, and it is significantly greater, often several times higher, than the motor's normal rated operating current. The excessive current flow generates a substantial amount of heat within the motor's windings. If this condition persists for an extended period, the motor's insulation can degrade, leading to premature failure and potential damage to the motor. To safeguard against the potentially damaging effects of locked rotor conditions, electric motors are commonly equipped with protective devices. These devices are designed to monitor the motor's current draw and take action when the current exceeds a predetermined safe level. Two common types of protection devices are thermal overload relays and circuit breakers. Thermal overload relays are designed to mimic the heating characteristics of the motor. When the current exceeds a safe level, the relay's internal element heats up, eventually tripping a contact that interrupts the power supply to the motor. Circuit breakers operate on a similar principle, but they use a magnetic or thermal mechanism to trip the circuit when an overcurrent condition is detected. Locked rotor conditions can arise from a variety of factors. One cause is an excessive load on the motor. If the load is too heavy or if the driven equipment is jammed, the motor may be unable to generate enough torque to overcome the resistance and begin rotating. Another possible cause is worn or damaged bearings. Worn bearings can increase friction within the motor, making it more difficult for the rotor to turn. Misalignment of the motor and the connected load can also contribute to locked rotor conditions. Misalignment can cause excessive stress in the motor shaft and bearings, hindering rotation. Loose electrical connections within the motor or in the power supply circuit can also lead to locked rotor conditions. Loose connections can cause voltage drops and reduce the motor's ability to generate torque. Problems with the power supply, such as low voltage or voltage imbalances, can also prevent the motor from starting properly. It is important to identify and address the underlying cause of a locked rotor condition to prevent further damage to the motor and ensure its proper and reliable operation. Failure to address the root cause can lead to repeated motor failures and costly downtime.